All right, so you'd like to learn something about 110 through 120? Here we go. Number 110, it says evaluate this function, f of x, is equal to 7x minus 1. And you want to evaluate it at x equals 2. Basically, when you're evaluating a function, you are sticking something in for x. So when they say to evaluate it for x equals 2, I'm basically going to put in a 2 wherever I see an x. This is another classic substitution situation. So I'm going to substitute in, instead of the x, I'm going to put a 2. And I'm going to say f of 2 is 7 times 2 minus 1. So f of 2 is equal to, 7 times 2 is 14 minus 1. So f of 2 is 13. Okay, so all you're doing is taking a function like this, and if they tell you that x is 2 or x is whatever, you stick that number in, and you'll be able to find your answer. So that's evaluating a function. Moving on. Which test will tell you if a graph is a function? Well, if you've got a graph of some equation or some function, and I'm trying to decide if that is a function or not, I can use what's called the vertical line test. I take a straight up and down line, and I run that line across my function. I see if it ever touches it twice. Okay, this one, the red one, would be a function. Except maybe at the very end here, it kind of looks like it might touch it twice. All right, so I'm going to get rid of that, and let's draw you something that would not be a function. A circle, for instance, is not a function because if I run my vertical line across it, it touches it twice. What the vertical line test is really trying to do is show you that at an input of, let's say, let's move this over to positive territory, it'll make more sense. Let's say that I'm at 2 over here. If my input is 2, then I'm going to put my line right there at 2. I'm saying that that input of 2 has 2 outputs. This right here and that right there. So it has 2 outputs, or 2 f of x's, you could say. So one input has 2 outputs. That breaks the rules, and you can't do that. So that's called a vertical line test, and it tells you if something's a function. It should never touch twice like that. All right, this is also a question about being a function or not. And when they give you a bunch of points, what you're looking for is trying to decide if it's a function by looking at inputs and outputs. The first numbers, those are all inputs. Okay, x's are like inputs. And then the y's, what comes out, is the outputs. So if you look at my inputs, I have 2, 2, 3, and 4. And my input of 2 had an output of 3. And then the input of 2 had an output of 4. And that is going to break that vertical line test. Or another way to say it is that one input has 2 different outputs, and that's not supposed to happen. So your function, this is not a function in this case then, because it's breaking the rules about inputs and outputs. So if you don't want to use the vertical line test, if you want to talk about it in other ways, you'd be saying that any one input should only have one output. So if you ever have the same input and 2 different outputs for that, then you know it's not a function. And if it's not a function and it's still paired data, we usually call it a relation. On to the next thing. Sketch y equals x. All right. Well, anytime you want to sketch something, you can always make an xy chart for it and just pick numbers, any number you want. If I pick 0 and I stick in 0 into my function or my equation, I can put in 0 there, and y would have to be 0. So 0, 0 would be a point on my function. If I want to stick in 1 for x, then y would have to be what? 1. So it's 1, 1. So if you just have it memorized, there it is. That's kind of a rough estimation, but that's about y equals x. Okay, it can be called the identity function. Next up, y equals x squared. All right. This one, again, if you ever want to, on any of these, you can just make an XY chart. Pick any numbers you want for X and Y. So if I pick 0, it would be 0 squared is 0, etc. But I have this one memorized because I've done this a lot, and I hope you do too. If I go over 1, 1 squared is 1. So over 1, up 1. Go over 2, it's up 4. And if I go over 1 this direction and up 1, and over 2 this direction and then up 1, 2, 3, 4, you'll see that it has symmetry There's my function y equals x squared. It is a parabola. This is also known as a quadratic. All right, moving on. Next one here is y equals absolute value of x. Y equals absolute value of x is a kind of a V-shaped function. Again, you could do an XY chart and you'd find that it goes just like this. And the basic logic is an absolute value can have two different things that would equal the same thing. So if I plug in 1 for x or -1 for x, either way, if I put in a 1 or a -1, the answer either way is absolute value of that is 1. So either way, I have 1 for my height. Okay, that's why you get the two results for each one. All right, moving on. Y equals square root of x. This is another parent function that you should have memorized. If I go over 1 and up 1, it's because if x is 1, y is the square root of 1, which is 1. So 1 comma 1. Over 4 and up 2 is the next logical place. If I make x 4, then the square root of 4 is 2. Okay, and this one keeps going forever like this. All right, that's the square root one. The next one is y equals x to the third. This is the cubic function. And if I stick in 1, it's 1 cubed, which is 1 times 1 times 1, makes 1. So 1, 1 works. And over 2 and up 1, 2, 3, 4, 5, 6, 7, up 8. So it would be about there. It's off my graph, but it looks something like that. Okay, so that's the cubic parent function. On to the next one, y equals 2 to the x. All right, this one is an exponential function because it has an x in the exponent. All right, so if I stick in some numbers, go back to my xy chart here. If I stick in x is 0, do you see why anything to the 0 is equal to 1 will make this be, if x is 0, y is 1. That has to go through that point. Okay, and then if I stick in x is 1, then I've got a 1 here. 2 to the 1 is equal to 2. So over 1 and up 2. If I put in a 2, I have x, 2 to the second, which is 4. So over 2 and up 1, 2, 3, 4. And then I go to a 3, and 3, x to the third, 2 to the third, 2 to the third would be equal to 8. So that's going to go off my graph again. More interesting is then you go to get smaller numbers and you put in like x is 1/2. If I put in x is 1/2, 2 to the 1/2 power means the square root of 2. Okay, so that's going to be a small number, a decimal, a number less than 1. And this will get closer and closer and closer as we move towards negative infinity, but it will never touch. All right, so there is my parent function for the exponential. Moving on. When looking at y equals, I don't know, I hope you can read this at home, negative x plus 2 squared minus 3, what are the transformations from the parent? Well, if you strip away all the fanciness, this boils down to y equals x squared. It is a parabola at heart. And you should be able to read these changes. This is very important. The ones that are on, the changes that are on the outside of any grouping symbols that you have, like parentheses or like square root symbols or absolute values, the stuff on the outside moves up and down. And so this negative on the outside is an up-down reflection. So it's going to take my parabola and make it flip up-down. Okay, if I'm flipping up-down, that means I'm going like this. That means I'm going across this, which is the x-axis. This one's the y-axis, right? So if I'm doing an up-down flip, I'm flipping over the x-axis. So this is a up-down flip, or technically a reflection over, if it's up-down, it's going over the x-axis. Okay, that is a move of 2 to the left. And you might feel like that plus 2 should be moving it to the right, because when we move to positive numbers, they're to the right. But everything inside here is always counterintuitive. It does the opposite of what you'd expect. Now, the minus 3, that is on the outside, so that's an up-down kind of a change, not a left-right. The stuff on the inside is left-right. This is an up-down change, and if it's -3, it was moving down 3. All right, so this one is reflected over the x-axis because of that. It is 2 to the left because of this, and it is moved down 3 because of the -3 over there. All right, moving on. F of x is equal to 1 over x. All right, what's the domain of f of x? Well, if f of x is equal to 1 over x, then domain is what numbers can and can't I put in for x. Because the inputs are the domains. They're also the x values. Okay, so what x values or inputs can I put into this function? Well, I can put anything I want in there, but some things will make the answer impossible. Like I could put in 0 here, right in here for the x. If I put a 0 in there, then I'll have a 0 in the denominator, and that's not okay. Because 1 divided by 0 is an error. It's a undefined point. And so my point is that you can't put 0 in. You could put any other number you want in there, and you won't mess up this function. But if you had put in a 0, you'd have a problem. So what we're saying is, if you think of this as a number line, 0 does not work. It's an empty spot on the number line. Everything else works. Okay? So I'm going to draw my little graph of what that kind of looks like in 2 dimensions. And then I could write it with intervals. That's what we usually do. And we're going to say that our domain goes from -infinity up to 0. And it can't be -infinity because you could never get there. And it cannot be 0, so we put a parenthesis. And if it could have been 0, we'd put a bracket. But union with 0 to positive infinity. Okay? So that's how you'd write your domain of f of x is 1 over f of x equals 1 over x. The domain of that is right here. Okay? It's the numbers that you can and can't put in. And this tells us that everything would work except 0. Moving on. Oh, that's it for now. Yay.